and thank you for coming today. Sorry for the brief delay in beginning. This is Richard Bernhardt. I'm with Streakwave Wireless, and we're doing a presentation of Streakwave Wireless Webinars today with WaveRider-by-Vecima. And we're going to be going through a number of products to tell you about how Waverider works, some of the special areas that they function in, and how those applications, or what applications will work with their products. First, I want to go through a little bit about who Streakwave is, because it'll be important to you if you want to purchase these products. Streakwave is a global value-added wireless broadband distributor. We distribute products for the broadband in both the licensed and unlicensed spectrum, and we are focused on the wireless broadband area. We have very specialized sales account managers who can help you with planning if you need to know where things will work, what kind of products will work in what environments, and the kind of applications will work. We can answer questions across a wide variety of product brands and types. WaveRider-by-Vecima is one of our lines as a master distributor, and we are trained and certified in that area. And we are, as we stated, a value-added distributor of wireless equipment, which means that you can get a lot of services by looking at www.streakwave.com or calling us at any time at 888-604-5234. One of the advantages of being a master distributor is that we can do a number of things for you, such things as path calculations and analysis. We can do ordering that is very rapid and can deliver to just about any point in the United States within 3 days, and often shorter periods of time than that, depending upon the availability of product in stock. And we can facilitate licensing for you. So as a master distributor for WaveRider-by-Vecima, it's my pleasure to introduce Craig Trask, who is the product manager, account executive for Waverider at Vecima, and he's going to give you an overview along with James Truman, who's a technical person and a product manager for both Vecima and Waverider. They're going to tell you about the company, they're going to tell you about the products, and so it's my pleasure to now introduce Craig Trask. Welcome, Craig.
Thank you, Richard. We appreciate the opportunity to be here today and to work with such a fine partner as Streakwave. Today, what I'd like to do is take an intriguing inquiry into what wireless users are looking for in this industry, how the technical features of the Waverider product line are targeted at addressing those needs, and we'll cover such issues as capacity, scalability, range, interference. And in addition, along the way, we're going to explore many of the vertical market applications for Waverider radios and look at some real-life situations and scenarios in which we've actually deployed product. I'm really glad that you're able to be here with us here today and look forward to running through this exploration with you. It promises to be a lot of fun. So let's get into our first slide right away. What I've tried to do is look at the world from a wireless user. And from a wireless user, I thought to myself, what is it that they would really want if they had their wireless utopia? What things would be the most important to them? And then we'll look at these things and see how the Waverider product line helps you meet these types of goals. Now, the first thing that comes up, of course, is coverage. In an ideal world, we would have a single base station, and it would cover everything. You'd never have to put up another unit. But of course, we have physical limitations in this universe as far as I understand. And things like the curve of the Earth, radio signal dissipation as a result of absorption and diffraction are certainly going to prohibit this from happening. We can also look at owning the frequency to ourselves. If we had the sole use of the frequency ourselves, that would be absolutely fabulous for us. We could use it however we want and whenever we wanted, and in whatever capacity we wanted to use it in. But again, we're going to have guys like the FCC who have other thoughts on how we might be wanting to use this spectrum, and they're going to jump in and tell us exactly what the rules and regulations are around it. And of course, the other thing is, how are we going to isolate ourselves, particularly since we're talking about ISM band radios, how are we going to isolate ourselves from other users of that band? Also in this wireless utopia, being able to have scalable networks would be absolutely ideal. In a perfect world, again, we'd have networks that could be expanded exponentially. We'd add users, we'd reach into different vertical markets, and we'd be able to do all these things as opportunities presented themselves. And then the other thing that we have to look at is, well, what would happen if we had networks that just operated all by themselves? I mean, imagine if you just opened up your crates, they set themselves up, and you never had to do any maintenance. Now that would certainly be utopia for us. So to help put our conversation into some sort of perspective here today and to give some context with it, I'm just going to quickly give you a very brief overview of what the Waverider product line looks like. And the important points here really are that we design and manufacture point-to-point, point-to-multipoint broadband wireless equipment. We have base stations, we have CPEs, we make a variety of different flavors for each of these. In today's discussion, we're going to look mainly at our unlicensed products in the 900 megahertz, although we also have some other products in the 4.8 or 4.9 and the 5.8 gigahertz for point-to-point. Okay, so let's get back to the thrust of our whole discussion here, and let's look at the wireless requirement of our fictitious utopia that we talked about, and that is being able to go forever with your radio waves. Now, as I mentioned before, the Waverider products are in the unlicensed band, and out of the unlicensed bands of 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz, 900 megahertz is by far and large the king of distance. And from the slide, you can see that the Waverider product line is capable of non-line of sight ranges of 2 miles, and of up to 2 miles, and line of sight of up to 25 miles. And if you'll recall from our opening slide, we recognize that in this ideal world, we'd be able to reach all of our users from a single base station, no matter where they were located. And while we can't quite do that with the Waverider product, we can reach out there a long way. And of course, the question to ask yourself is, well, why is this important? Well, simply put, it allows you to reach more possible revenue sources as a user with the lowest possible capital expenditure for your base stations and towers. Now, the other thing I wanted to just give you here quickly was a general rule of thumb that we call the half again rule. And basically what it says is that all other things being equal, that is, you have the same output power, you have the same terrain, you have the same height of towers. When you go from 900 megahertz to 2.4 gigahertz, you should expect your range to reduce by about a half. And that would also hold true if you went from 2.4 to 5.8 gigahertz. And so you can see how important it becomes now that you maximize your deployments at lower frequencies if you possibly can, to ensure that you minimize your capital expenditures. I want to go through a bit of a case study here to start out with now that talks a bit about how important it is to have long range. And here's an actual rollout that we've done with the police department in Indianola, Iowa. And it's an excellent example of this real-life rollout that we've been talking about that benefits from the long-range capability of the 900 megahertz products. In this area around Indianola, the area is characterized by rolling hills and mature trees. And so the need for a solution that has both good non-line of sight and line of sight capability is paramount, especially since the data that is going to be transmitted through these Waverider networks is critical to the safety and efficiency of the officers in the field. And so what they've done is they've deployed 4 towers. They're able to reach about 90% of the town, and they're able to communicate effectively through to the officers in the field using our Waverider radios. In this case, they're using our mobile units, which we'll talk about a little bit further in detail as we move on. Okay, so let's look at our second item on our wireless utopia list. that was the sole use of a frequency band. Now, as I mentioned before, the Waverider products operate in the 900 megahertz ISM band. And as such, of course, they're subject to all outside interferers as defined by the FCC rules. So clearly, we're going to have interference in this band. And I think, in fact, if you were to ask people within the wireless industry, almost everyone would agree that the 900 megahertz spectrum is really nice from the coverage perspective. You go a long way, you have great penetration through trees, etc., but it can be really crowded and noisy. And so now what we need to say is, well, how are we going to get around that? How do we address those noise issues? And I think what you want to do is you want to divide the noise up into two different categories. You have internal noise and you have external noise. That is noise that comes from outside of your network. And if you look at the outside types of noise, I mean, these things are predominantly from things like baby monitors, wireless video cameras, cordless phones, all those types of things that are used on a daily basis by people we know. And of course, then there's the other 900 megahertz systems in there that are broadcasting for other ISPs. And of course, the other thing that has really impacted the market in the last little while has been automatic meter reading devices, as these have been rolled out in the 900 megahertz band also. And then the last issue you have here is the self-interference. That's when your radios are starting to interfere with themselves because they communicate to each other at the same time, and consequently your data doesn't get through. So let's have a quick look here and see how Waverider can help you solve some of these problems and see if we can get you a little bit closer to that wireless utopia. The first thing I'm going to talk about here is that all Waverider base stations have built-in spectrum analyzers. They'll conduct a sweep of your location and determine exactly what's going on in your 900 megahertz area or band in your particular area. Unlike some of the other products in the marketplace, that just look for their own radios within the area, our product will sweep everything from 900 megahertz all the way up to 930 megahertz to show you exactly what's going on. So using this type of data, you can now select what's the best possible channels for you to run your network on. And the other thing that I want to really point out to you here is that the Waverider equipment operates on 5.5 megahertz wide channels, and so consequently, you're going to have more choices than many of our competitors have because they're working with much larger channel sizes. The second way that Waverider products address this issue of external interference is through the use of diversity antennas. We offer options for both our indoor and outdoor radios to obtain radios with integrated diversity antennas. In the slide, you can see that we have an indoor unit here, and it's providing two different radiation patterns depending on which antenna element happens to be active at the time. The really good thing about all of our diversity antennas is that they switch automatically. You don't have to interact with them at all, and they're going to switch automatically on a packet-by-packet basis to ensure that you constantly have the best reception you can possibly have. Now, this is really important to our wireless utopia goals because, again, it's going to ensure that there are fewer maintenance calls to address intermittent data connections, and it dramatically increases the signal-to-noise ratio, which means that your radios are going to operate at higher modulation rates and you're going to have greater data throughput. So let's move on to our third quiver in our arrow in our quiver that addresses external interference, and that's filters. Now, our filters come in a variety of different bands. We actually have 7 different options here, and each of them are focused on allowing only the frequency that we want to have pass through. The filter sits between the antenna and the radio, and so consequently they only transmit through to the radio the signal that you're looking to get, and all the other signals are rejected. So if you have issues of multipath, you have delayed types of signals coming to your antenna, you can only get the signal you're looking for, and you don't get any false positives that way. The other external interference technique we have is adaptive modulation. And as you can see, we really take this external interference thing seriously, because we have 4 things already here that we've got for technical capabilities to address how to bust this interference problem. Adaptive modulation works so that it automatically adjusts the modulation rate of a subscriber according to the quality of the radio link that it's maintaining with the base station. So as the radio link degrades, it automatically adjusts the modulation, and you can see that we have QPSK, we have 16 QAM, we have 64 QAM, and as you go through those different modulations, it changes the data rates to each of the users. Now, the really good thing about this, of course, is that it's on a subscriber by subscriber basis. So your whole network does not degrade down to the lowest common denominator, which you see with some of the 802.11 type of base products. As such, it supports transient environment changes without suspending service, and it ensures that every user in your network is going to get the highest possible data transmission rate. And in wireless Utopia, the happiest clients are always the ones that have a reliable connection, and this, for the user or for the person who deploys the network, builds profitability, and it reduces your need for customer relations staffing. Internal interference is the other area that we talked about, and this can cause many problems, I guess, as external interference can cause. And we also need to make sure that you're not addressing that. And the Waverider product addresses that through what we call a dynamic polling MAC. Our approach to coordinating the communication timing between the base station and the end user is to poll each one of them and ask if they have any data to transmit. Now, while this may seem like it's a slow and potentially fraught with problems type of technique, what really makes it effective is the fact that it has a dynamic component to it. And what this means is that unlike some of the GPS-based systems that define a particular time slot to each of the end users and then have them transmit it in exactly that same time slot, the dynamic polling MAC notices when end users have more or less data to send, and accordingly, they will poll them more or less frequently to ensure that you're constantly being able to get the maximum amount of data based on who actually is active at the time. Of course, the proof is always in the pudding of these types of things, and the reality is that our MAC is so efficient that you'll see that we advertise here that it would actually be able to support up to 300 subscribers on a single base station. Now, while you may not want to have those types of numbers just because of the data rates that would be going through, the important fact here is you are able to technically support them. And if you're technically able to support them, that means that you can manage less number of users even better. And of course, the best thing about this capability is it's already built in to each of our base station radios. There's no additional charge for this capability. So let's have a look at another real-life example that characterizes the need for interference busters that we've been speaking about. Here we have a mining application, and the situation is this. There's a vertical mine shaft and an elevator that moves men and equipment up and down to the various horizontal shafts. In the past, what they used to do is the men used to reach out of this elevator and pull on a rope to signal the elevator to stop and to go. What we've done is we replaced that rope with a radio link and it's been implemented to replace a practice that obviously is very unsafe for the workers. Now, the shaft is a really difficult environment because it's wrought with multipath signals caused by the concrete walls and by the metal structure supporting the elevator. This creates a really unique interference issues, and we've addressed this through most of the techniques that we've actually been talking about just previously here. In the top left photo, you'll see that there's the filter we were speaking about, and that really helps with this multipath situation because we don't want to have those false positive signals coming through because the elevator would move at the wrong time. In the top right, you can actually see the antenna up at the top of the structure that holds the elevator. And then in the bottom left, you can see the box that's actually inside of the elevator. And then on the bottom right, we actually show you the radio that's right inside the box that we just finished looking at on the left-hand side there. In our third statement on what would make wireless utopia, we identified that it would be great if networks would operate themselves. And again, we have a certain degree of reality here, but the Waverider products really do go a long way to help you reduce the overall operation expenses of a network. Self-install units are an example of this type of leadership. The units are really simple to install. There are really only 1 or 2 cables that are needed to be connected. The power over Ethernet cable and a coax cable on units with external antennas. You just point the antenna in the right direction and as you can see here, we have an indoor unit shown. And on this unit, there's also a little bit of help there too. There's actually an LED that will blink faster and faster as the RSI improves to help you fine-tune the reception. So the important things are here that they're really easy to install and that there's no truck roll. Truck rolls equal expenditure. So this slide starts to tie into the whole seamless setup that we've been talking about. The Waverider end user units will automatically self-configure. Really, all you have to do is plug them in. And in fact, we have some clients, like the City of Buffalo, where a network operator has deployed a network that depends 100% on a self-install model. Users take the units out of the box. They're instructed as to which direction to focus the antenna, and they plug in the power over Ethernet cable, and they are up and running. Now, the base stations also have a similar feature to this, but although they will work straight out of the box, it makes more sense for them, for every operator, to take a few more steps in between. They should do things like set up, run the frequency sweep so they know which channel they need to set on, and of course, then they need to set the channel accordingly. They should define their management IP addresses, and they should also set up all the passwords internally. But again, in that wireless utopia, you do see that these products help to reduce your overall operating costs by self-configuring. Now, the last area where we really help with this managing of your network is through enterprise quality equipment. Enterprise quality equipment reduces operating expenses through fewer breakdowns, the need for ongoing truck rolls, and troubleshooting that can plague many of the networks out there. Waverider products, we have thousands and thousands of these units in the field, and they're designed to keep your network working seamlessly for years to come. The units that that are really built tough. The back plane of them is solid aluminum base. The unit weighs in at about 6.4 pounds. It'll operate from -40 all the way up to +50, plus the solar loading. And the whole enclosure is NEMA 4 certified. So just another reason why these products will help you in the long run to operate a network that will have the lowest cost. Then there's the network management piece. It's just another one of those nice-to-have type of tools that just makes it easier to set up and monitor the ongoing operation of any network. The tool is internet-based, as you can see, and you can access it from anywhere you have internet access. You can monitor and control the various functions of your network. And this is really a time saver for you because it releases you from being tied to a specific location to run diagnostics, to change any settings, or to collect stats. In our wireless Utopia, we also discussed the importance of being able to build out networks to meet the needs and opportunities as they arise. The Waverider gear provides you with all kinds of flexibility to deploy wireless networks. On the left there, you'll see a smaller type application where you could have a single base station with an omni antenna. That would support, as we talked in theory, up to about 300 subscribers if that's how you wish to deploy it. And then here in the middle, you can see a little bit larger type of deployment where you start to sectorize. Now we've shown a tri-sector deployment here, but in theory, you could actually have all 4 sectors set up if you had a completely noiseless 900 megahertz spectrum available to you because of the fact that we use 5.5 megahertz channels. And again, this creates really high capacity types of networks. And then, so if you start then looking to the right, you say, well, maybe we might want him to set up a satellite type of network in conjunction with our sector type of network. And so you can build that in too. We offer wireless backhaul units that are going to tie the whole network together. So from the Waverider perspective, we offer the products and capability for you to keep on building out your network as large or as small as you need it to be. And we have all of the products internally to do that within our product line, and they're all tested and verified to work together. Of course, to be truly able to build out networks, you have to have a range of products to make that happen. And here again, our Waverider product line is really extensive. We offer both indoor and outdoor base stations. If you note the CCU 8010 there, it actually comes with an integrated antenna, or it can have an external antenna. So it provides you with even more deployment types of solutions depending upon your environment. And again, with the end user units, again, we have lots of different flavors for the different deployment applications that you're going to run into. We have outdoor units, we have indoor units, some with integrated antennas, some with external antennas. They also come in fixed and nomadic, but we'll talk about the nomadic stuff a little bit further on here. So here's another example of how Waverider units are being used today. This time, we're looking at a traffic control situation. In this scenario, here in the city of Calgary, where I'm actually located at, they're using the Waverider radios to signal changes to control directional road lanes that are switched to make more lanes available for traffic flowing into the downtown core in the morning and then out of the downtown core in the evening. And in the first slide here, you can see that the radios are controlling a mechanical sign. This is a tri-sectored sign that will flip, and it'll change and say that this road now is going the other direction. And then in the next slide here, you'll start to see that we do the same type of thing, except we're now controlling an electronic sign. And here's the mobile products that we were talking about just a little bit earlier on. These units are a little bit different from our other radios. They use a different modulation scheme and have lower data rates in order to maintain a more robust link in a mobile environment. They will work completely through with our CCU base stations, so our standard Waverider base stations, so you can mix and match both the mobile products with the fixed products. So here's another example. In this case, what we've got is we have a client that is operating a pulp mill, and they are using the mobile Waverider units in conjunction with our fixed Waverider products. So here, the pulp mill is burning waste pulp in order to generate electricity so that they can operate the plants. And in order to run this system efficiently, they need to ensure that all of the incinerators, they have 3 different incinerators, and they need to have a constant supply of waste pulp to burn. And to ensure that the trucks are being used efficiently, what they've done is they've used the fixed Waverider radios at the incinerators, and they've attached those to a video camera. The video stream is then sent to the main office. It transmits the data out to the trucks where they can view they can view what is going on at each one of the bins, and they have a mobile Waverider product radio in their trucks, and then they're able to make decisions on which bin needs more pulp and deliver it to them in an effective manner. So to round out our product line, we also have point-to-point links at 900 megahertz, 4.9, and 5.8 gigahertz. The 900 megahertz radios are virtually the same products as we've been talking about in our point-to-multipoint scenarios in the past. The only difference is that they have a master-slave relationship established. But an interesting application for these units is to use them in a switch mode and to link them back-to-back so that you can extend reach. And so we see some of that happening in the marketplace also. The 4.9 and 5.8 gigahertz radios come in 2 different flavors. They come in both a single input, single output, and a multiple input, multiple output versions. And you have data rates of 50 and 100 megahertz or 100 megabits per second, respectively. These products are extremely good at handling that point-to-point type of application and sending either a little or a lot of data, depending upon what your requirements are. So one of the really big ideas that I want everyone to take away with them today is that this whole reality that while our products were originally designed for the wireless ISP network deployment, they have, and as a result of our diverse product line, been used in many, many different applications in many different vertical markets. As you can see, by this list that we have here of the applications, they're really quite endless. And in fact, I was speaking just recently with one of my colleagues, and he was telling me that he's got a client who's interested in using our radios in a farming application, in which they would use it in conjunction with a video camera to monitor activities in some of their remote buildings. So there's yet another area, that a vertical market that could be added to this list. My last example to you of a real-life scenario is a SCADA implementation. And in this case, the data from a wastewater system is being transmitted back to head office, where pumps and other equipment are being monitored. Implementing this system really has increased the efficiency and reduces the need that they have to physically go out and inspect each one of the pieces of equipment and to gather data from it. So just another example of how it is that you can take these standard 900 megahertz radios and you can use them in some of these really interesting applications and into these vertical markets that I guess initially you may not have thought they would they would be the perfect match for, but they really do work well in these areas. So in my last slide, I just want to now just give you some ideas as to why it is that you should consider using the Waverider products. I mean, we've talked about a lot of ways in which we're able to help you reach those goals of that fictitious wireless utopia that we've been looking at. But I just wanted to revisit some of those main reasons as to why you would buy the Waverider radios. And the 5.5 megahertz channel widths are really key to why Waverider radios work really well in real-life types of deployments. You know, with the smaller channels, you can get really high capacity, higher than most of our competitors. And the reason for that is that in reality, your chances of being able to utilize a full 20 megahertz wide channel that many of our competitors focus on and show you the high data rates for, that's virtually just not going to happen. You're going to be restricted in what you actually have available to you. You know, at Waverider, we also recognize that, you know, these ISM bands are going to be really noisy. And so, you know, we've built in all of those technical interference busting capabilities that you're ever going to need. And with the exception of the filters, they're all built in at no additional cost. The other issue that we've already been discussing extensively here is that Waverider has a broad product line, and all of our products, they've been tested to work together. We can provide you with the best one-stop shop in the industry by supporting both your point-to-point, point-to-multipoint, fixed and mobile solutions that you know, we just stand head and shoulders above everyone else in the industry in this regard. And lastly, the Waverider gear is built to commercial standards. You know, we have thousands and thousands of base stations in the field, and we have tens of thousands of subscriber units that are being utilized on a daily basis. I want to really thank everyone for your time today, and you know, I hope you've enjoyed this exploration into our wireless utopia. And I will now turn things over to Richard, and we'll have a little Q&A session after Richard's jumped in here for a moment.
Well, thank you, Craig. It's a very informative presentation by Waverider and an interesting overview of the 900 megahertz frequency area. As you can see, the Waverider product by Vecima provides a fairly broad base of application uses and solutions. As Craig has up on the screen right now, usable in farming and enterprise, education, government, hospitality, public safety, and one that I was looking at particularly that's a hot area these days. I don't know how many of our viewers are watching this for that particular reason, but as a termination for IP security and surveillance. You had mentioned to me at one point that Waverider excuse me, utilizes a QoS system. And imagine that allows you to channelize the types of signals that go through. Do you want to talk a little bit about that?
Certainly. There are a variety of different grades of service that we're able to establish within the radios. So as a operator, you can define what sort of grade of service that you wish to apply to each of your users, and accordingly, you will each user will then be established at that particular grade of service. And so if you have, you know, a user who is, say, a gamer, and he needs a lot of data coming very rapidly so he doesn't find himself suddenly killed because guess what? He's 2 milliseconds behind what his competitor is at. You can establish those types of relationships so that that gamer is going to have a certain quality of service. And of course, from a operator perspective, that leads you to an opportunity now, of course, to potentially have different pricing models. The other thing that we are able to do is, we haven't talked about this at all, in the presentation, but the Waverider products will also support VoIP. And so consequently, if you need to have a VoIP type of application built or utilized in conjunction with the Waverider products, we can certainly support that also.
Great. Just one thing that usually comes up when we do these presentations, so let me put it in here. If you came in the middle or you wanted to watch any portion of this webinar, again, Streakwave Webinars does reproduce its webinars on the landing pages for each individual manufacturer. So WaveRider-by-Vecima will have this available so you can replay it. It'll also be on our YouTube channel. So if there's any portion of this webinar that you'd like to see again, it will become available in the next couple of days. Can you talk a little bit more about how you talked about ease of installation. Do you have alignment tools? You said there was a spectrum analyzer built in. You might want to talk a little bit about what makes it easy to install.
Well, I guess there's a couple of things. As we already have discussed, the units really will self-configure to a large extent by themselves. And you know, as I mentioned before, with the indoor units, they actually have an LED on them that flashes more readily as you start to get the stronger RSSIs. We also have an additional tool that is available, and it's typically sold in part of our kit type of arrangements. But the tool does a similar type of thing. It allows you to see what your RSSI is and make sure that you're pointed in the right direction. And it's a little handheld tool. And if you're an operator, you know, once you've got one or two of these, your field people, if they need to go out and do any troubleshooting, or if you you know, you want to send it out to people so they can do a self-install because they're far away, and you know, they may need a little more help to walk through it, you can certainly do all those types of things. And it's a very simple type of tool to use. We have obviously have complete documentation on how it works and what types of capabilities it has.
The interference portion of Waverider's products, obviously 900 is both a great frequency for going distances, but also is one of the most populated frequencies. And you mentioned that you deal with interference, and I imagine you use different kinds of filters and so forth. Can you talk about how you filter the signal?
James, this might be a good one for you to jump in on, the technical capabilities of how filtering works.
Well, filtering is not quite magical like we'd appreciate it to be, but it certainly blocks out adjacent carriers. In the 900 megahertz, we have interference from paging up on the top side of the band. On the bottom side, you can have interference from various other sources. So that just helps the radios differentiate the frequency that it wants to listen for versus what is coming into the receiver on it.
Okay. One of our viewers has asked about multipath signals, and can the radios be set to multicast, and are multipath signals reduced by the filtration?
Multipath certainly is reduced by filters by some degree.
Okay, good. Can you talk about security a little bit in the radios, both the base stations and the access points? How do you control them and set them up, and then how do you secure them?
Mm-hmm. When you provision it, you instruct the base station, the CCU unit, as we call it, to allow a certain MAC to connect. Once it does connect, they authenticate and exchange a secure key by which they can transmit and receive data between each other, so that other subscribers, of course, can't listen in, and that other sources out there can't listen or transmit into their data path.
Okay, and it uses a digital controller, I gather, or some sort of GUI that you can use to set up the system.
Yeah, it's either web-based. Radius is another platform which it supports, which helps the the extensibility and scalability of the network as you build out. Multiple base stations can use the same radius server, and then monitoring is over SNMP.
So turning back to the base stations themselves, you mentioned that you could have as many as 300 subscribers, and I would imagine that 300 subscribers is not something that would be realistic on a base station very often, although you could technically support that many. What is the throughput on, what would you expect the throughput to be on an average system, and how would that be chosen?
Well, actually, Richard, that's kind of an interesting question, and I guess there's a couple of things. One, if you start deploying this type of radio in a SCADA application, for example, you may need 300 users, and so that's one thing to consider. That if you have some lower data requirements, you are able to support a large number of users in that type of environment. The other thing is that, in reality, we typically have situations where users or operators are supporting, somewhere between 50 and 75 subs on a single CCU. They're using maybe about a 10-to-1 oversubscription ratio, and they are running good data rates at that rate out to each of the users. Sometimes we also have some operators who write their own back office type of scripts that allow them to limit various types of subscribers to different types of scenarios. So, in these types of cases, it's not uncommon to see, typically between 1 and 3 megabits per second in supporting, that sort of 50 type of subscribers on a real user type of rollout.
So I think the obvious answer is it depends upon what the type of users you have and their kind of burden. You said there's QoS, so if you were managing voice over internet protocol or you were managing IP video, you'd have to judge the availability of how much bandwidth you want to allocate for that. And in the end, you set up your system to best serve the type of clients you're using. And SCADA is a low drain system, so it's just digital in and digital out, so it doesn't require a lot of data source. The next question that came up is how many channels are available with the 5 gigahertz band? Can you talk a little bit about the 5 gigahertz band for a bit?
Are you talking about the point-to-point units here, Richard?
I think so. One of our users asked about the 5 gigahertz band and wanted to know about the channels available.
Okay. So let me just think here.
He confirms to me that it is point-to-point, yes.
Okay. So, the frequency band there is from 5.470 up to 5.875. So consequently, we run those units in, I'm just trying to remember now, James, is that in a 20 megahertz wide channel?
It's either the 20 megahertz or 40 megahertz for MIMO unit.
Right.
Generally, we operate in the top 125 megahertz or so of that band.
Mm-hmm.
Up in the 5750 to 5875 range for North America.
So it really depends then upon whether you're using the CISO units or the MIMO units, mm-hmm. Whether how many channels you're going to get. So, yeah. If you're using the 20 megahertz wide, you have about 6 channels, and if you're using mm-hmm. the 40 megahertz wide, you're down to about 3.
Great. Okay, guys, we're about running out of time, so what I wanted to do was mention a little bit about where you can get this product. Obviously, Streakwave is the master distributor for this product, excuse me, and you'll find a complete listing of products for Waverider at streakwave.com on our website. And If you have any other questions that have not been answered here today, I'd be happy to answer those questions for you. We can pass them along to Waverider, or we can answer them from Streakwave through your sales manager. And an address will be provided to you for questions, or you can send to richard@streakwave.com. I'm happy to answer any questions. I'd like to thank Craig Trask and James Truman of WaveRider-by-Vecima for their presentation today. They've given us a good overview and analysis of the Waverider line, and also an overview of the 900 megahertz products and how well they fit into all kinds of applications. So again, on behalf of Streakwave Webinars, we'd like to thank you for coming today. If there's anything we can answer for you, please call upon us, and watch for other editions of Streakwave Webinars from across all different kinds of products within the wireless broadband world. Again, thank you for coming today, and we'll see you again next time.